Share my screen. I'm gonna need to plug this in. Okay. So let's look at file IO stuff, and I want to talk about a couple of the pieces here, because actually the next assignment was this one. But we'll do something with file IO unrelated to that. Well, I'll just show it and we'll leave it at that. Okay, so we do have one little weird thing to deal with file IO here in Eclipse. So let me get Eclipse opened. And this is something you would not have to deal. Why is it dark? We still see that okay? Or would you rather it be a lighter color? No difference? All right. I've just never seen it dark like this. So what I'm going to do is, actually, I'll keep it inside of this Bible book thing because it's going to lead us to our next path. So I'm going to go into driver, and I will delete the stuff after our Bible book stuff from in here. Because remember last time we were talking about static versus non-static? Remind me, what's if we're looking at the method definitions, a static method looks like what? If we're looking at where the method is being defined, how can we tell the difference between a static method and a non-static method? Yeah, word static is there when we're seeing it being defined. If it's an instance method, we won't see the word static there. Now, if we're calling a static method, how do we call a static method? Using the name of the class in which the method was defined. How do we call a non-static method? Using an instance of the class in which the method was defined. Okay, these are things that we should have not just memorized, but practice using moving forward. We saw two examples last class of why we might have instance methods versus class methods. We saw that the string class is filled up with a whole bunch of instance methods. Why is it filled up with a bunch of instance methods? Because we want to create multiple instances of strings to hold different contents, right? You know, you might have 30 different strings that hold different strings. And we want to have a bunch of methods that know how to operate on that particular string. So if I ask for the length of the string that is hello, I get a 5. If I ask for the length of the string that has elephant, I get an 8. Those types of things. So string class would be filled up with instance methods because we are typically operating on instances of things that already hold values. We also looked at the character class last time, as well as we've talked about the integer class, and we kind of saw that there's a class kind of for all of our different primitive types that exist in Java. And we saw that those are filled up primarily with a bunch of static methods. Why is that? Well, we already have the ability to hold data. We know how to hold a char. We know how to hold an int. So we don't really need new ways of doing that. But we did need a class that allows us to operate on those values. With that in mind, well, Why? Because we might want to do stuff to chars, right? We might want to convert a char to uppercase. We might want to ask if a char is actually a representation of a digit, stuff like that. So rather than creating multiple instances of characters, when we already know how to hold char values, we created a single character class that we can think of as kind of being like a factory class that we can send things into that character class, give it a parameter of a char, and it can operate on those values. Okay, so that's kind of a rationale for why we might have class methods versus instance methods. Now, that doesn't mean you can't make an argument either direction. You know, you could just say, well, the old char primitive type is kind of antiquated, and we might as well just use characters for everything. In fact, the modern version of Java lets you get away with that. It'll treat it, it'll treat them both the same if you just want to use character with a capital C for everything. But we want to learn the language from the perspective of not hiding stuff from us. We want to work with, you know, the primitive aspects of the language, and then looking at the tools that allow us to enhance that knowledge. The character class gives us an enhancement to our ability of working with chars, because our primitive types only allow us to hold values. That's all they can do. So if I have a char C is equal to an A, all C can do is hold a value. If I need to start doing things to that char, I'm going to need an external component. So I either need to write some code myself that allows me to do some stuff to that char, which I can convert it to uppercase, right? We know chars are stored as unsigned 16-bit integers. So I can do the math to get the uppercase version of a lowercase character. I could certainly write a function for isDigit that tells me whether or not a char holds the number, the Unicode value that is the numbers for 0 to 9. You know, I could write all those functions. The character class has all those written for us, so that it's a nice convenient tool that we can use whenever we need to test something or do something with char primitive types. Okay, so that idea of instance versus class methods, how do we use them and how do we write them? And then probably to a lesser extent right now, why we would write them, but still you should have that starting point of understanding the why. Should be something that we should be getting very, very comfortable with, because it unlocks the entire Java documentation for you. Okay, so what I'm going to do here, we're looking at which homework, who's this homework 5 that I'm operating in? Yeah, it is. So what I'm going to do is I'm going to go ahead and I'm going to create a file. So I'm going to right click on my package. I'm going to say new.
We can't see Eclipse on the Zoom call.
Really? I wonder why. Shared my whole screen.
Now we can. Thank you.
Oh, maybe it's because I started the recording and started the share before I plugged in the. So actually, I'm going to do something here real quick. I'm going to pause the recording just in case something in the recording would have done something funky. Because I plugged in my HDMI after I'd already started the share. All right, so I'm going to go in here to my default package. I'm going to create a new, and I'm just going to create a file. This has nothing to do with Java. I just want to create an empty document. I'm thinking about what are external ways I can get stuff into my programs, right? Because right now we've either hard-coded stuff or asked the user for some input, right, with the scanner.
XML or JSON?
Well, XML and JSON are ways that we can format information externally. So that's certainly involved in either file IO or you know, talking to third-party APIs or something. What we're really talking about right now is the various mechanisms for getting data into our program. What you just talked about, XML versus JSON, is what does that data look like? Putting that data into a format that's conveniently usable for us. So related, but not the same thing we're talking about right now. So this semester, at least, what we've done so far is we've hard-coded values in our code. We've asked the user for some input, then operated on that user input. Now we're going to add a third level, which, interestingly enough, is something that's somewhat fallen out of favor in the modern era of programming. In fact, some programming classes never even cover file IO. Rationale being that, you know, we can say it's not commonly used anymore, but that's actually a lie. It's just not cool to be used anymore. So, you know, file IO, we have a local files on our computer, right? So we have, in this case, we have a Java program, and this program is going to operate on data. Well, that data can live in different places. Now, we might say, well, isn't it better to pull let's say I'm writing an app that deals with stock market pricing, something like that. And we want to pull a current stock price over the internet because that's the most up-to-date data. I can't hard code that in a file on my computer. Well, that's all fine and good. That's a good place to pull that kind of data. But there's plenty of things that are static values that might not change very often, or don't require or only change when you change them, that would be better for it to live on your computer rather than rely on an internet connection to get it, right? This is actually kind of a misnomer. A lot of you might be gamers, right? And one of the things when we ask about, you know, people say, oh, you need to have a good internet connection to be a video game player. I think we actually mentioned this in here a couple weeks ago or something. I was talking about the internet connectivity, internet connections. Was that in here or a different class? But, well, regardless. So what does good internet mean for a gamer? What does it mean to have good internet at home? As technologists, we should all be very familiar with the technology that's around us.
It depends if they're online gaming or not.
Well, let's just start with the good internet. What is it? How do we measure the speed of our internet at home?
Megabits per second.
Okay, megabits per second. So that's what they're selling us, is number of megabits per second, right? Now, megabits per second gives us an indication of what's our maximum theoretical download speed. That's what we're buying. Now, that's going to help us if we're downloading large files or certainly not illegal movies, right? You know, things like that. But, you know, if we're downloading something big, software patches, stuff like that, having a high megabits per second theoretical rate, you know, we're not always going to get that rate, but having that theoretical maximum is going to be good for us. But do we care about that if we're a gamer? You'd rather have lower megabits per second and much lower latency than you would to have really, really, really fast megabits per second, but high latency. High latency is delay. You're playing one of these first-person shooter games, and you have a 300 millisecond or 3,000 millisecond ping. Usually it's ping is what it's measured as, or latency. A lot of times the little bar in your game shows it as red. You know, things are happening in a 3-second delay for you. And so basically you're playing those first-person shooters as if you're me playing them in real time, which is not very good. I'm usually dead before the game starts, or right instantly as it starts. So gaming today requires us to have real-time response rates, right? You know, if we're talking about online games, that's especially true, but really any kind of gaming. So we can talk about where are the bottlenecks in our program. So one of the things we run into problems with in a multiplayer type gaming situation is latency. When you make your move, everybody else needs to be aware of your move as quickly as possible, right? But the way that your move is sent between those different computer programs, usually the game client on those different computers, is over the internet. And we're not sending all those graphics and stuff like that, right? We don't need high bandwidth for that. You know, we're sending little chunks of text. You know, maybe it's a JSON string, an XML string, or just, you know, a comma delimited set of coordinates or something like that, that we're just shipping over the internet. It's getting distributed to all the other people that are playing your game to make your version of their character on their screen move to the right place. So it feels like you're all in the same shared world at the same time with very, very little latency. Make sense? So from a gamer's perspective, fast internet is low latency internet, where the communication time between you and the server is very, 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 very fast. The amount of data you're having to send for gaming is actually not very high. You don't have to send that much data. But our games today, minus this game he's addicted to, typically have amazing graphics, right? What's the name of this game? Among Us.
Oh, Among Us.
All right, I'm going to add it to my to-do list. I'll try it out.
That one would be best to play with the group.
It's very popular nowadays.
Is it? Interesting.
It exploded recently.
Called Among Us.
Yeah. Use Discord, there's servers. Talk to people.
Actually, it would have been really good. I had a lot of you knew I had knee surgery last year. I had a flare up this last week, so my knee's been killing me. So this weekend I was on a nice cocktail of pain meds. This would have been a great game, I think, to play during something like that, maybe. But
Kind of like those games where you used to like sit around in a circle with a bunch of friends, and you know you have like a bad guy who's like the murderer, and you're trying to like figure out who that is. But
you're talking about the board game Clue.
Yep.
Oh, that one.
Yeah. We're talking about the board. Yeah.
All right. Well, I'll try it. I'll try it during the presidential debate tonight. All right. So, in any case, outside of this type of situation, usually we think about our games as being, having beautiful graphics and stuff like that, 4K, whatever, blah blah blah. Those are not things that you're going to want to be sending over the internet in real time while you're playing your video games. Okay, that's actually part of the problem with some of the what's it called, Stadia, that's trying to stream games. One of the issues it's going to run into is it's very, very reliant on maximum bandwidth of your internet connection, because those graphics and stuff are not living locally on your machine. Okay, so punchline here is that generally speaking, at least in our modern high-end gaming or whatever, we have lots and lots and lots of stuff that live locally on your computer. When you download pick your favorite games video game client, you have 30, 40, 50 gig downloads, right? What do you think that is? Do you think that's a bunch of text files? Or you think that's huge image files that are super high resolution that it's just storing on your hard drive because that's the fastest way to get it onto your screen? Okay, so having local files feed data into a program is still very, very much a core part of any software development. It's just not cool sounding anymore because we've just been doing it since day one, so it's no longer kind of a thing. But we're going to start initially looking at using some file I/O to get stuff into our program so our program can maybe persist between runs of the application. And then we're going to move towards, we're going to see this in Java, and then we're going to start building objects out of it and things like that. So what I'm going to do is I'm going to create a new file. This is a generic whatever file, so I'll create a new file. I'm going to put it, it's asked me where I want to store it. I'm going to put it in my source directory. I'm going to purposely do this. I'm a little bit inclined to put it into the bin directory, but I'm going to put it in the source directory, which is the default. And we're going to call this guy, I don't know, input.dat. Let me actually just see, what did I call it in my slides? So I call it the same thing. Yep, input.dat. Input.dat is what I'll name that file. Okay, so what I have right now, I have a text file. I just named it .dat. It doesn't matter what you name it here because we're going to tell Java what file to open. So typically when we have a file that has an extension on it, like if you see a .doc or .docx, that's a Word document, right? So those are called Mime types for a file. We're inventing our own here. So .dat maybe means data, .txt typically is a Mime type of text. But whatever it is, we're reading it in as just plain text. Okay, and I'm going to go ahead, I'm going to put cat, dog, elephant in here. Just fill it with some stuff. All right, this is offline data that I want to get into my super high resolution video game we're writing. We're bringing in a couple of strings. Okay, so now what we need to do is we're going to create a scanner. Just like when we're reading in from the keyboard, we're choosing to read in from a different place. So our scanner here is going to be built in terms of a different input stream. Okay, and the input stream is going to be a file, and I'll talk about this here in a second. So we're going to go ahead and create a new scanner. So I'm going to go back to my driver.java. We'll create a scanner. Call this guy, I'll just call it input, is equal to a new scanner. All right, now we'll go ahead and import java.util.scanner. So I'll hover over this guy, import java.util. Okay, so now we know about the scanner class, and we want to build this guy in terms of, instead of system.in, which is our keyboard, we want to build it in terms of a new file object. So let's go and look quickly at the Java file class, now that we know how to read documentation. And we're going to look at the constructors for a file. One of the constructors is we have 4 different ways of building a file. The one that kind of makes sense to us is the path name. We're going to give it the path on the local hard drive where this file lives. So a way of creating a file is through a string that is the path name. And this is where things get a little bit complicated with Eclipse, because when we run our Eclipse program, it runs it out of the bin folder. But my source code lives in the source folder. So this isn't a Java thing. This is a how does Eclipse organize your project thing. And since I put my code inside of the source folder, we can cheat a little bit and get the user directory from something called system.getProperty. Now, before we look into this, what kind of animal is getProperty? Now, most of us have never seen this before, right? What I'm asking you to do is, based on what we've learned over the last class, to tell me what are we likely seeing in the wild here. So if I just look at getProperty, what kind of animal is getProperty here? Is it a variable? Is it a method? Is it a class? What is getProperty?
It's likely a method.
Likely a method. How do you know?
Because it has get property and it's calling system. Or it's
I'm going to look at the getProperty part here. So if we're just looking, I agree with you, it's likely a method, but I want to know, why is this likely a method? If we're, forget about the system dot before, just the getProperty, the things I'm circling over here. Why is that guy likely a method? Go ahead. The parentheses. Yeah, this guy takes parameters. Methods take parameters, right? Methods and constructors take parameters. We know this guy's not a constructor because it doesn't seem to have the name of a class. How do we know it's not the name of a class? Because it's not capitalized. It's likely not the name of a class. So because this guy uses camel case, getProperty, starts with a lowercase character, it's likely the name of a method or the name of a variable. How do we know it's probably a method? Because it has open and closing parentheses, so we see a parameter list. So getProperty seems to be likely the name of a method. Now, is it a class method or an instance method? And how do you know? Is it likely a class method or likely an instance method? Go ahead.
It's likely.
Okay. Go ahead, Emily. I think
It's likely a class method. Yeah. It's likely a class method because the system is capitalized.
Yep. So since we see system here being capitalized, we say system is likely the name of a class, because classes are typically, by naming convention, capitalized. So now we're seeing the name of the class call the getProperty method. So this guy is likely a static method. So if I were to go and look at the system class, we'll just deviate here. We'll come back to this. We'll say Java system class. And we scroll down and we find the getProperty method. Here's our getProperty method. Takes in a key. This guy is a static method. Make sense? Notice how we were able to identify what we think it likely is by how it was being used. And that's all from what we learned about last class. So This is a superpower, understanding those things, because it's going to open up the entire Java documentation to you. But in any case, one of the things that we have, we can get all the properties if we want, but one of the things that we have is the ability to ask the system some questions about our current environment. All right. So one of the things that we might be interested in here is, tell me what my current user directory is. This is the name of one of the keys. And it will tell us the current directory is that source directory. Make sense? So it gives me that starting point for the, well, actually, it gives me the current user directory of the Eclipse package, which I can then say, well, off that directory, take me to the source, and then take me to input.dat. All right, so we're going to create a scanner here using a new file using system.getProperty to create that file, or to find that file. So scanner, we're going to say we want a new file. We're going to use system.getProperty. The name of the property is user.dir. That's the user directory. Okay, so this guy right here, system.getProperty, we just saw, is going to return for us a string. Here's get property. It's going to give us a string. And one of the things we can do to strings is we can concatenate them, right? So I know that I stored my file input.dat inside of the source folder. So I'll concatenate onto this guy /source.
Looks like you deleted what you had down.
Yeah, I saw that. Give me a second. Ay, ay, ay. I'll concatenate onto that /source/input.dat. That's the name of my file. And then I'll go ahead and I'll import java.io, which is where file lives. All right, so now I've created a scanner out of a new file, looking in the current directory, and I'm concatenating onto that /source/input.dat. So this just gives me the full path of where that file lives in the current system. Kind of have to play this game with Eclipse because Eclipse runs your program out of a different directory than you're writing your program in. Otherwise, you could have just put input.dat and it would look in the current directory. But the current directory, go ahead, I'm sorry.
What if you put your file you're trying to read in the directory that they run stuff out of?
Yeah, remember when I first started doing this and say I'm kind of inclined to put it in bin? I think it would work then. You could just put input.dat. So I think it's running it out of that bin directory. I think that would work.
What is the bin directory? Is that the overall directory, underneath?
No, it's the directory that every single time you hit the play button here in Eclipse, it copies your .class files into that bin directory and it runs your program out of that directory. But this is probably the better way of writing it, by putting it along with your source code or in a directory within your source code directory so that somebody else could compile it and run it on their computer or something. Because consider if you went and shipped your Java program off to somebody, one of the things you'd want to do is have that program be just an executable for them. You'd run it as something called a jar, rather than them having to download Eclipse and open up your project and hit play. It's probably not, like when you go and get your latest, greatest video game, you don't open up Microsoft Visual Studio and launch the project and hit play. You double click on a .exe and it runs, right? Okay, so I promise it was built this way to start with, but then they created a package installer that ultimately gives you an executable that brings everything together. Okay? So we're kind of just playing the Eclipse game here to make sure that, and it's not even the Eclipse game. Really what we're saying here is, look, wherever this thing is running in the computer, in this case it's running in Eclipse, but if I copy this into a whole new directory, wherever that directory is, go to the source directory and then the file called input.dat from that. So now we've made the code portable, right? Doesn't matter where we've stored it, as long as that input.dat is sitting in a folder called source/input.dat off our user directory, this will work. All right, now notice it's currently yelling at us because there is a exception that could get thrown here. I think I've talked about exceptions a little bit, but we're going to talk about it more now. So the exception this guy can throw is probably something called a file not found exception. I'm basically saying, look, I'm going to create this scanner around this file that I've claimed is called input.dat. But oh, by the way, it might not be. It might not be called that. So when I hover over this guy, it'll yell at me and says, unhandled exception, file not found exception. So what can I do? Well, the best thing to do for these, we have two different options for handling exceptions. We can do something called a try catch, which allows us to attempt to do something and then potentially catch the exception. I think we've seen it. I think I've written it a couple of times before, but we'll talk about it in much more detail right now. Or we can just pass the buck. So technically, if I want to be lazy here, I can just say throws exception up here on main. And now I'm just saying, look, anything bad that might happen inside of here, remember all programs begin and end with main. I'm saying anything bad that happens in here, I don't care about, it's main's problem. So I'll go ahead and throw this exception, and then my program will just crash. Just the way it'll go. So if something bad happens, it just crashes. It worked 20 years ago, why can't it work today? Sometimes programs crash, right? It's just the way it goes. So this would be the lazy way of doing it by just saying, I'm going to pass the buck. It's going to be somebody else's problem. So any exception that happens in here, I'm not even saying file not found exception. I'm saying I'm going to throw all exceptions. Anything bad that happens inside of main, I'm going to leave it up to the Java virtual machine. Go ahead, have at it, crash, whatever it is. Okay, kind of lazy programming, but hey, it works and don't have to write as much code in here, but we'll show the better programming practice version of this. So Eclipse has now warned us that, hey, it's underlined this in red because, you know, something bad could happen there. Now we know that we created this file called input.dat. We know where we put it, so we don't think it's likely that this will be a problem. But somebody could go in and delete that file, right? So bad things could happen. So what we're going to say is, you know what? I'm going to go ahead and I'm going to try to do this. And actually, if you hover over this, you can choose to surround with a try catch. It'll go ahead and put it in there for you. And then I'll just reformat it the way I like it. All right, so now it's saying, look, I realize that bad things can happen inside of this try. I'm going to try to do this. And if everything works fine, no problem. We'll just let it cruise and not worry about it. But if something bad happens, rather than my program crashing, I'll go ahead and catch. In this case, I'm specifically catching a file not found exception because that's the bad thing that can happen with this particular line. Because we can actually have multiple catches with a single try. Let's say inside of this opening and closing curly brace, I had 10 different things that could go wrong. I could have a catch for each of those 10 things. And it would catch the correct one. I could deal with each one of those things individually. Alternatively, I could just say catch exception E, which say anything bad that happens, just catch it, handle it. But the question is how do I handle it? My handling of it is what's in here. Right now, I'm not handling anything except I'm saying, I know something bad can happen here. I'm going to catch that potentially bad thing. And what am I doing to handle it? I'm just going to print it out to the screen, the bad thing that happened. So effectively, what I'm doing right now is the identical thing that the Java virtual machine would have done.
So I got a quick question about this.
Sure.
Okay, so does like Eclipse always tell you what these exceptions are, and when you're, or is it like something you just kind of have to know sometimes?
I don't know if always is true, but I would say a very high percentage of the time, Eclipse knows the problem that something might throw.
Okay, also, so when you're doing these like catch the file not found exception, is that something you name, or is that something that you're like calling?
This is the type. My variable name here is E. I
Okay.
can call this guy LOL if I
So
want.
there's multiple types of like exceptions then.
Correct. So there exists an exception class that has a whole bunch of children. So there's a top level exception, and then there's sub exceptions under that, and then there's sub exceptions under that. So these are children through object inheritance.
So would you recommend that we just use the automatic feature, just doing this automatically, or do you want us to like look into the documentation to figure out which exception we should be using?
Well, I think the automatic thing is very convenient, because I mean, if you look into the documentation, you know, you might only notice one exception that could happen. So this is a nice feature that Eclipse gives you. So I guess the question is this: I would say take advantage of the fact that Eclipse tells you what exception could happen with a particular line of code. Good programming practice would be to handle each of the possible exceptions appropriately and separately. So that means if inside this try I had 3 lines of code, and each of those 3 lines threw a different exception. So maybe there was a file not found exception, maybe there was a you know, an exception like from integer.parsent, like the thing's not a number, you know, something like that. You should have 3 different catches for each of the 3 different kinds of exceptions. That's what would be the appropriate good programming practice. Now the reality is you should only write a try catch if you intend to do something in the catch. So in this case, I might say, well, what would be the appropriate thing to do if I tried to open up a file and that file wasn't created? Well, maybe the appropriate thing to do would be to tell the user you need to first create the file, contact system administration. You've seen things like that before, right? You know, the error messages that pop up on your screen. You know, another thing you could do is ask them for the actual name of the file in case this file didn't work and they wanted to point to a different file. You could ask the user for input here. Say, hey, I couldn't find the file you told me to look for. Can you tell me a different location for input.dat? Maybe they moved it. In this case, I don't really have something that I want to do. I'm kind of just going to assume, since we're looking at this as an example, that, you know what, this is probably just going to work. I'm not overly concerned, and just printing out the stack trace is just going to give me that error message of, you know, this is what I did, then this is what I did, and oh, I didn't find the file. So this is not really doing anything special right now. So if I'm being honest with myself as a programmer and understanding the situation I'm in right now, I would probably just say, I'm going to throw the exception up here. So I would take that out of there. I would write that line. And then if I wanted to be maybe a good Samaritan about this, I would say throws file not found exception. At least then I'm saying I realize that this specific bad thing can happen in my code. And because of that, I'm going to throw that to the next level up. It just so happens I'm currently in main, so the next level up is the Java virtual machine. If you have a class that you have this code in, and you wrote this throws inside that class on the whatever function you're in, it would throw it to the next level up of your code of whoever called upon that method. And then you would have to deal with it there. You could then choose to throw it again and just keep passing the buck, hot potato style, right? You could make that work. So in this particular case, because I don't necessarily intend to handle this error with anything special, I basically am accepting the fact that my program is going to crash if it can't find this file. And that's okay, because we want this code down here to be as clean as possible as we're working through it. And if I'm not going to intend to write something special to handle, this is called exception handling. If I'm not going to write something special to handle this exception gracefully, then I'm going to just pass it. Pass the buck, especially now that I'm in main and I'm passing the buck to the Java virtual machine. I'm just saying, look, show me the error message as you crash. But I'm doing it now for the right reason, as opposed to, oh, I just need to get the red squiggly line to go away. That make sense? All right, so this line could cause a problem, but I'm going to go ahead and throw that exception. I've accepted the fact it could cause a problem. I've decided I'm not going to deal with it myself. So I'm just going to let the Java virtual machine scream at me and give me the nice red text of what went wrong. But maybe the where I'm acting in the middle here is I'm saying I'm going to throw specifically a file not found exception here rather than throw anything that is an exception. Because I can choose somewhere else in this code to have another try catch that handles a different kind of exception that maybe I do care about handling. I do want to do something special with, something like that. Okay, so now we have our scanner. So now that we can read in from this file, I think it's called has more elements is the, as well, has next. So we're going to go ahead and say while input dot has next. So what this guy does is this function returns true if there are more things to read inside of this scanner. We know it's a function. Why? Because it starts with a lowercase letter and it has an opening and closing parentheses. So we know it's a function. Is it an instant? Is it a class function or an instance function? We know it's an instance function. How do we know? Because we're calling it with input, which is an instance of the scanner class. So if I went into scanner and I looked at the has next method, I would find a non-static method called has next that returns a Boolean. How do we know it returns a Boolean? Well, I'm using it inside of a while loop right here that requires a Boolean expression, which is any expression that boils down to a single value of true or false. So these processes, these things I'm saying out loud right now, you should be going through these processes as you're writing your code. What do you expect something that you just wrote to do? When you see a line of code, what does this line of code mean? Eventually you'll start doing it automatically, but right now you should maybe be saying it out loud, right? Who is this guy? He's a variable who holds an instance of the scanner class. What is he doing? He's calling a method. How do I know it's a method? Because it has the opening and closing parentheses. What kind of method is it? Must be an instance method. Why? Because I'm calling it with an instance. We have a lot of information about what we're dealing with here just by kind of investigating the material that's in front of us, the evidence, right? All right, so as long as I have another thing I can read in, I'm going to go ahead and I'll just do a system.out.println input.next. I usually read a next line because that'll get it to the end of the line with the carriage return. Now when I run this, you see it read in from my file, my external file, my 3 lines, cat, dog, elephant. Now, because I'm done reading, I should say input.close. I should close that scanner, saying that I'm no longer reading from it. All right. Make some sense? Next thing is, so now I have things I'm reading in from a file, 1 line at a time. They're strings. Once I have them in the program, I can do whatever I want to those strings, right? So if I want to have my file here, input.dat, if instead I want to have it be comma delimited, where it's all 1 line and everything is just separated by commas, I go back into my driver, I run this again, I'll just get 1 line now, but now it's a comma delimited line. So now I don't even need to say while input has next, I know there's only 1 thing in there. So I can just print out the 1 thing that's in that because I know the nature of my file. So there's that 1 thing. I've just decided I'm going to put my entire contents of my file inside of a single, on a single line separated by commas to get my individual pieces. Okay. Now, what if I want to split this guy up on commas? first thing is what kind of animal is this? When I read this in, it's coming in as a string, right? You know, if I want to, I can say dot length, and it'll tell me there's the length of that string, 16 characters. All right, so I can go and look at the string class and see that and ask, are there things that the string class knows how to do that might make my life easier here? Actually, I can shortcut to the string class by clicking here on string, because that's what this guy returns, so I can get to string. So what I'm looking for here is there a way for me to split a string up on delimiters? So we'll take a guess and say, oh, maybe it's called split. So here we have a split function that splits on a regular expression. We're going to treat it as just a delimiter. And what does it give me as a result? It gives me a string array. We do not see static here, so that means it's an instance method. How do we call instance method? Using an instance of the class in which the method was defined. What class was this method defined in? It was defined inside of the string class. So I need an instance of the string class in order to call the split method. So I can come in here and I can say something like, we'll call this guy string file contents is equal to input.nextLine. And then I'll go ahead and close my scanner. I'm done using it. Okay, now I have inside of my string file contents. So now I can go ahead and say string array, I'll call this guy file parts, is equal to file contents dot split on a comma. Now if I say system.out.println file parts dot length, we'll get a 3. Notice here, if we're again playing our game of kind of figuring out what we're looking at, what is length right here? What kind of animal is length? Is it a field? Is it a method? Is it a constructor? Is it a class? Which of those is it? And how do you know? Extremely exciting. The level of participation. What's length there? How do we know it's not a method? Lately, our guesses have been method, right? How do we know this guy is not a method? What are we not seeing here that would make it a method? Parentheses, right? Okay. So, not a method. So what must it be then? Well, now we whittle it down. It could be the name of a class. Now, can it be a constructor? Constructors also have parentheses, right? So it's definitely not a constructor. So we've actually kind of gotten rid of constructors and methods. Can't be one of those. It could be the name of the class, name of a class, or it could be the name of a field, a variable. Okay, which of these is this? How do we know it's likely a variable? Good. Classes are typically capitalized, yeah. I want to keep driving that point home that it's not a law, but you could pretty much bank on that. This guy is not capitalized, so he's probably not the name of a class. So he's the name of a variable, presumably. Now, the reason I bring this up is notice if I say system.out .println, and we'll call this guy file contents.length. Notice the difference here. File contents is a string. File parts is an array of strings. Arrays have a length field that tells us the number of elements in an array. It's a variable that boils down to those number of elements. Whereas strings have a what? What is this guy here? What kind of animal is that?
It's a method because it has parentheses.
Yep, method, because it has parentheses. All right, so they both do the same thing, right? The string one gives us the number of characters in the string. The array one gives me the number of elements in the array. It just so happens the array one has chosen to represent this as a field called length, whereas the string has represented this as an instance method called length. Somewhere behind the scenes, they made this decision. I'm not sure why, but that it is what it is. So we're just seeing right next to each other, both of these give us the length of a collection. But one's so when we're dealing with arrays, the length is done through a field, not a method call. Where with strings, it's done through a method call. It's just is the way it is. Okay, so I'll see here that I have my file parts as 3, but the file contents length was, I don't know, 18 or 16 or whatever it was, 16. So here's my number of buckets that I had as it split my thing into 3 parts. So now I can go through each of those 3 parts. I can say for string s in file parts, system.out.println s, and that'll get me my 3 pieces from that array, cat, dog, elephant. Notice that arrays are iterable, so I can use my for each loop here. So this is like in Python when I used to say for s in file parts, something like that. That would have been the Python equivalent to that line. So I can write it that way, or I can write it as a traditional for loop. For int I is equal to 0, I is less than file parts dot length, I plus plus, and then I can say system.out.println file parts at bucket I. So both those loops ultimately will spit out to the screen the elements in my file parts array.
When I'm running this, I'm only getting cat coming out, not the other 3, or other 2.
Okay.
Huh. I don't know.
So your code is different than mine.
Oh yeah, my code's different. Okay.
One way or another, your code is different than mine.
The input's different. Okay. I see you had that all in one file. I missed that you changed that to one line.
Yeah, I made it comma delimited here. That way we can look at our split function.
Yeah, I see you changed that. I must have missed that whenever you were doing that, so that's my bad.
So there's my cat, dog, elephant, and cat, dog, elephant again. I went through that array 2 times, but I went through it different ways each time.
Okay, I'm good now. I was just confused as to why my code looked exactly like your code. I was just copying it down, and then why it wasn't doing the same thing yours was. So I figured that out now.
Okay, so now we have our parts. So we have this nice convenient method called split that we can pass this is technically a regular expression, but we can, for right now, just think about it as, the delimiter that we want to split a string on. So we can go through and we can, get our individual pieces of this guy. You might find this handy in the next homework assignment, as you're going to be reading in a collection of Bible books, where you have the information about the Bible book stored in a file, and you're going to bring them in. You're going to create a bunch of instances of Bible books, and then do stuff with them. So if we're going to kind of go down that path just a little bit, I can go in here and I can say something like, well, let's say that for a cat, we're going to keep track of the name of the animal, maybe the number of legs. Well, they're all going to have the same number of legs, so we'll put a spider in here. So number of legs, and then maybe a weight. So we'll say this cat is 7 pounds. Then we'll have a dog, number of legs, and weight, maybe 30 pounds. Like it's a medium-y sized dog, right? I think. Elephant, number of legs. And then we'll call this guy, I don't know, how much does an elephant weigh? 6,000 pounds? Like 3 tons? I think 3 tons is like it's probably about what an elephant weighs.
Okay, it depends on the type of elephant.
Okay, do we ever
The
average?
African forest elephant is 6,000 pounds.
Oh, see?
Asia elephant is 8,800 pounds, and the African bush elephant is 13,000 pounds.
All right, so we'll put Littman in here. 2 legs, and I weigh $120. All right, so per leg. But then we have to add in the top part. Oh, yeah. Here, we'll. And then let's get a spider in here with 8 legs, and spiders weigh nothing, right? So just so we can keep everything as an integer, we'll just say a spider weighs 1 pound. They probably exist, aren't they? They have those bird-eating spiders, don't they? Yeah, not all of them. I mean, I saw some, I don't know, some Discovery Channel thing. There's this like bird-eating spider. Yeah. It thing's like the size of a Frisbee. Yeah. That'd be awesome. We actually had that happen at our, this is when I used to teach at Western Illinois University, Macomb, Illinois, years ago. This must have been 20 years ago. And we had ordered, I don't know, my wife ordered some kind of patio furniture, and it must have shipped from somewhere overseas. And so we set it up in the backyard, and I guess there was a spider living in it, not like a bird-eating thing, but some spider that was not native to Illinois. So this thing had created this web system in our backyard that was like right out of the movie Arachnophobia. So we called the exterminator that came out. He had to bring one of their scientists out to try to identify the spider. And I think it turned out it wasn't like anything super venomous. It just looked way scarier than it should have been. I mean, the spider was the size like my hand. It's pretty awesome, actually. All right, so as a kind of a starting point for maybe the direction you're going to be going for your homework, I've created this file that has a whole bunch of different lines on it, with each line having some information about an animal. Where an animal is going to have a name, it's going to have a number of legs, and it's going to have a weight. Okay, so what I'll go ahead and do is I'm going to now create a new class in here. So I'll create a class called animal to represent my new object type that I want to have. That's going to keep track of a name, a number of legs, and a weight. So for my class, I'm going to call this guy an animal. All right, we're going to have a private string name. We'll have a private int number of legs, and we'll have a private int weight. We'll go ahead and create our constructor for this guy. So public animal is going to take in a string name, an int number of legs, and an int weight. This dot name is equal to name. This dot number of legs is equal to number of legs. This dot weight is equal to weight. All right, and I'll go ahead and I probably want to allow myself to have getters for the, remember last time we talked, a couple times ago, we talked about setters and getters. So I made all these guys private so that I can't change them externally, but I'd like people to be able to get the information about an animal's name, number of legs, and weight. So I'll go ahead and give myself getters for these. So I can either write public methods like public string get name that returns this dot name. So I can do that myself if I want to. Or I can also right click out here. I can go to, was it source? Generate getters and setters. And I can choose for number of legs and weight to have getters for both of those. And it'll rate them for me. So convenience, this is something that IDEs give us, that Eclipse, I'm sure NetBeans has a way of doing it. Any of our IDEs that work with object-oriented languages have conveniences like this for generating functions that always would be generated the same. Well, they don't have to be. Like, you don't have to call this guy get name. You can call this guy woot if you wanted to. But get name kind of makes sense for a function that allows you to get the name. Hence the reason we called it get name. But in any case, this guy rates it for us to save us a little bit of time. All right, and then we'll go ahead, and I like to write a little display function. In a lot of my classes, just to kind of quickly check to see whether or not everything kind of worked out the way they should have worked out. So let's see, I think I've shown you system.out.printf before, right? For formatting. So we're going to create a string here. We're going to say name is %s, age is %d, weight is %d, and then I'll do a carriage return there. And then we'll say this dot name, this dot age, this dot weight. So these are placeholders. %s is a placeholder for a string, %d is a placeholder for a decimal. It's possible it's %i instead of %d here. In C, it would start off as %d, and then they let you do it as a %i. But in any case, I know how to create these guys now. Now, one thing I'm going to do is I'm going to say, you know what? I can create an animal with all three of these pieces of information. But maybe I want to be able to create an animal another way. Maybe I want to create a second kind of constructor. Because I know that my animals are coming in, I'm reading them in a line like this. Maybe I could pass it a string, and it goes ahead and splits that string for me and sets the parameters. That would make it pretty clean, right? If I had that secondary ability, another way of creating an animal. Instead of giving it 3 different pieces of information, I can create an animal giving it 1 piece of information and have it break it apart and set the individual fields. That would make my main look cleaner, right? So what I'll do here is inside of animal, I'll give myself a second constructor. We'll just have this guy take in a string. Actually, let's call it comma delimited. Delimited. Is that spelled right? Well, let's just pretend maybe. All right, so I'll go ahead and I'll say string array parts is equal to comma delimited dot split on the comma. So that'll split it. Then I'll go ahead and say this dot name is equal to parts at bucket 0. This dot number of legs is equal to, now it's going to come in as a string. I need to get it as an int. Do I have a way of converting a string representation of a number into an integer representation of a number? What's that tool called? integer.parseInt, parts at bucket 1, and this dot weight is equal to integer.parseInt, parts at bucket 2. Because parts is filled up with 3 strings. The first of those strings is the name. I don't need to do anything special to that. The second one of those strings is the number of legs, but it's stored as a string. I want to get it as an integer because I've decided to store it as an integer inside my code. Similarly, the third element is the weight. I also want to get that as an integer. Make sense? I could decide to do it like this. I could have this be a double. And then this guy would be parse double. There's another is it called parse double or parse float? Oh, sorry. It's not. It's double dot parse double. Double dot parse double from parts at bucket 2. So again, these are functions for operating on, here we have a double primitive type for operating on other types. So I'm passing it a string representation of a double, and it's going to parse that double out, and I'm going to store it inside of a variable of type double. By doing that, I can now go in here and say that my spider is actually 0.1 or something like that. That's still a pretty big spider. 0.01, let's go with that. Okay. So that is my animal class. I'm storing 3 different pieces of information. I have 2 different ways of building them. I'm probably going to rely heavily on the second way of building them because that second way of building them is going to give me the ability to just pass it my string and have it go ahead and build it for me. And then I know how to display and I know how to call some different things, but now I have an error because this guy now returns a double. So I need to return the weight because I changed my type for my weight. All right, so now out in driver, do I have any other errors in here?
It needs to be number of legs, not age.
Oh, thank you. Okay, so now we'll go back out here to driver. I'll go ahead and read in. So I'm going to go back to the thing I had here before. So I'll say while input.hasNext. I'm going to read in a string, but I want to build. So I will go ahead and say I'm going to build an animal. A is equal to new animal. And I'm going to build this animal using the second constructor, input.get. So, oh no, it's just next line. There we go. So I'll build my animal out of input.nextLine, which is going to give me that comma delimited thing, and then I'll say a.display. So it wants all of those things that are doubles to have decimal points in them. I believe. Oh, actually, that wasn't the case. The case is this guy. I think it wants it as a float. for my placeholder. Yeah. So there's my cat, dog, elephant, Littman, spider. Read them all in. I created ages out of them. Now I just happen to know that my thing has 3, 4, 5. I have 5 elements here. I could certainly create an array of animals and fill it up with animal objects to work with if I wanted to. Nothing keeps me from saying something like animal array AR is equal to new animal array of size 4. That's allowed. And then I could put bucket 0 of that is one of my animals, bucket 1 is another animal, bucket 2 is another animal. Just like having an array of strings, I can have an array of animals. Make some sense? All right, so your next homework assignment is very similar to the previous homework assignment, except you're going to be working with a file containing information about your Bible books. And then here's your delineators. So book name, followed by a colon, followed by number of chapters, followed by a colon, followed by a summary. So instead of commas, we're using colons. And you're going to read in Bible books. And this is going to be all of the books in the New Testament. So you're going to create a input.dat file for all the New Testament books only with those summaries and that kind of stuff. Sound good? So you already have your Bible book stuff. I will push this code for it was the previous homework 4. So you'll have the file AO stuff from that and those changes. And I'll put this assignment up and I will see everybody on Thursday.
I'm Dr. Littman.
Yep. I saw you wanted to chat. Let me stop the recording and stuff. Give me a second.
Yeah, so I know that Hackathon Club was planning on doing a department